Dear students, welcome to the second session of Quadrilaterals. In the first session, we have discussed the properties of a parallelogram and the sufficient conditions for the quadrilateral to be a parallelogram. We have also done exercise 8.1. Now today, in this second session, we shall be doing midpoint theorem, converse of midpoint theorem, and some questions of exercise 8.2. If we have a triangle ABC, if D is the midpoint of AB and E is the midpoint of AC, and if you join this DE, then DE is parallel to BC according to midpoint theorem. Midpoint theorem states that in a triangle, the line segment joining the midpoints of two sides of a triangle is parallel to the third side. AB and AC इस triangle की दो sides हैं और इनके midpoints को जो join किया एक line DE से, that is parallel to the third side BC. Now let us prove this midpoint theorem. Now we have to do some construction here. Through C, we are drawing CX parallel to AB. CX parallel to AB. Now let us extend this DE to intersect 2 point Y such that it intersects CX at P. Let us now take these two triangles ADF and triangle this one CPF. Now in these two triangles, since by construction we have drawn CX parallel to AB, so these will be the alternate angles. These two are parallel lines and AC is the transversal. So alternate angles are equal. Moreover, it is given that AF equal to FC. First, these angles are equal. This angle is equal to this. Alternate angles, then this side is equal to this side because F is the midpoint of AC. Now, vertically opposite angles will also be equal. So, by ASA congruency, triangle AFD, triangle AFD is congruent to triangle CFP. These two triangles are congruent. Now when these two triangles are congruent, by CPCT we have corresponding parts of congruent triangles are equal. So by CPCT we have DF equal to PF and this will be equal to AD will be equal to CP by CPCT. Now here we see that AD equal to CP. Now AD is also equal to DB since D is the midpoint of AB. So we can say that AD equal to CP equal to AB. AB equal to CP equal to DB. This will be DB. Now AD equal to DB, or from here we can say that CP equal to DB. CP, this CP is equal to dB. And CP is also parallel to dB. CP is equal to dB. We are getting CP equal to dB and CP is parallel to dB. Now the sufficient condition for a quadrilateral to be a parallelogram is that if any one pair is parallel as well as equal, then the quadrilateral becomes a parallelogram. So this BCPD is a parallelogram. When this is a parallelogram, so other pair will also be parallel. So this implies that DF is parallel to BC and also DF will be half of BC. Now here we have proved the midpoint theorem that in a triangle the line segment joining the midpoints of two sides of a triangle is parallel to the third side. It is also half the third side. That also we have proved how it is half the third side. This DP will be parallel to BC and since DF equal to FP, so DF will be half of BC. So in a triangle, the line segment joining the midpoints of two sides of a triangle is parallel to the third side. Now what will be the converse of midpoint theorem? Converse of midpoint theorem will be that in a triangle, if a line is drawn through one point of a triangle parallel to another side bisects the third side. What does it mean? If you have a triangle, for example PQR, and if this is the midpoint, say L is the midpoint of PQ. Now if a line is drawn through the midpoint of one side of a triangle parallel to another side, it is drawn parallel to QR, line is drawn parallel to QR, so it will bisect the third side. This third side will be bisected at M, that is PM will be equal to MR. So this is all about midpoint theorem and the converse of midpoint theorem. Now let us take first question of exercise 8.2. This exercise is based on midpoint theorem and the converse of midpoint theorem which we have discussed just now. Now let us solve question 1. Question 1 is ABCD is a quadrilateral in which PQRS are the midpoints of the sides AB, BC, CD and DA. AC is a diagonal. Show that, now let me first draw the figure. ABCD is a quadrilateral. ABCD is a quadrilateral. PQRS are the midpoints of the sides AB, PQ, BC, CD and DA respectively. AC is the diagonal of the quadrilateral which is also given. Now show that SR is parallel to AC and SR is half of AC. Now in first part you have to show that SR is parallel to AC and SR is half of AC. Now let us take join, these are joined, PQ, QR, RS and SP are joined in the figure. Now let us first take triangle ACD. Now in triangle ACD, S is the midpoint of AD. S is the midpoint of AD. R is the midpoint of CD. R is the midpoint of CD. Therefore, SR is parallel to AC and SR is half of AC. Just now I showed you that in a triangle, the line segment joining the midpoints of two sides of a triangle is parallel to the third side and is half the third side. Now second, we have to prove that PQ equal to SR. Now for second part, that is PQ equal to SR, we will take triangle ABC. Now in triangle ABC, similarly as we have proved above, P is the midpoint of AB, Q midpoint है BC का, so PQ will be parallel to AC and PQ will be half of AC. If you take triangle ABC, in triangle ABC, PQ will be parallel to AC and PQ will also be half of AC. No, but we have to prove that PQ is equal to SR. Now, how to prove it? Here in part 1, SR is half of AC. In part 2, we have proved PQ is half of AC. In other words, we can say that PQ equal to SR equal to half of AC. Hence, PQ equal to SR. Okay. PQ is equal to SR. Now, PQRS is a parallelogram. Now, since PQ is parallel to SR also and PQ is equal to SR from these two statements, so PQRS is a parallelogram. So that's all for today. Thank you.